Hello everyone, this is J. Manasa Bindu from EC department. I am pursuing BTech first year. Graduate Srinivasa Ramananda Institute of Technology from Anantapur. I am explaining my subject is engineering physics. Subtopic is clausis-mossotti equation. Introduction to clausis-mossotti equation. The clausis-mossotti equation is a fundamental equation in the field of electromagnetism. It relates the polarizability of a material to its dielectric constant and the refractive index of the medium. This equation was first derived by Rudolf Clausius and Augusto Mossotti in the 19th century. Derivation of Clausius-Mossotti equation. The Clausius-Mossotti equation is derived from the Lagrange equation, which relates the refractive index of a medium to its dielectric constant. The Lagrange equation assumes that the polarizability of a material is proportional to the square of its refractive index. By substituting the Lagrange equation into the equation for polarizability, the Clausius-Mossotti equation is obtained. Importance of Clausius-Mossotti equation in optics. The Clausius-Mossotti equation is particularly important in optics and the study of light and matter of interaction. It helps to understand the behavior of light when it passes through or interacts with materials. By knowing the dielectric constant of a material and the refractive index of the surrounding medium, one can calculate the polarizability and predict the optical properties of the material. Limitations of Clausius-Mossotti equation. The Clausius-Mossotti equation assumes that the material is isotropic, meaning its properties are the same in all directions. It doesn't consider the effects of magnetic field or anisotropic material. At high frequencies or in the presence of strong electric fields, the Clausius-Mossotti equation may not accurately describe the polarizability of a material. Applications of Clausius-Mossotti equation. The Clausius-Mossotti equation has numerous applications in various fields including materials, science, optics, and electromagnetic theory. It is used to understand the behavior of light in transparent material such glass or polymers. The equation also plays a critical role in design and optimization of optical devices such as lenses, waveguides, and photonic crystals. The induced displacement the directly proportional to the local field, nu proportional to EL from equation 1, where alpha is equals to polarizability, L is local field. We know that P is equals to nu L, where P is equals to polarization, where N is equals to number of atoms per unit value. Substitute equation 2 in equation 1. P is equals to N proportional EL from equation 3. We have local field EL into E plus P by 3 epsilon naught in equation 4. Substituting equation 4 in 3, P is equals to N proportional into E plus 3 by epsilon naught, equation 5. Next, P is equals to N proportionally E plus N proportionally P by 3 epsilon naught. P minus N alpha by 3 epsilon naught is equals to N proportionally E. P into 1 minus N proportionally by 3 epsilon naught is equals to N alpha E. P is equals to N alpha by E. 1 minus N alpha into 3 epsilon naught from equation 6. But we have P is equals to E into epsilon naught E or minus 1, equating 16 and 7. E into E epsilon naught E or minus is equals to 1 into 1 or minus by 3 epsilon naught. 1 minus N alpha by 3 epsilon naught minus N alpha by epsilon naught into E or minus 1. 1 minus N alpha 3 epsilon naught plus N alpha by epsilon naught into E or minus 1. N alpha by 3 epsilon naught is equals to 1 by 3 into E or minus 1 plus 1. n alpha by 3 epsilon naught is equals to e r minus 1 by 3 epsilon naught into e r minus 1. N alpha by 3 epsilon naught is equals to e r minus 1 by e r plus 2. N alpha by 3 epsilon naught is equals to 1 by 3 by e r into minus 1 plus n alpha is equals to 3 epsilon naught e r minus 1 plus 3 epsilon naught into minus 1. In alpha 3 epsilon naught is equals to epsilon r naught minus by epsilon r naught plus 2. The above equation represent as clausis-mossotti equation. Conclusion. The clausis-mossotti equation is a fundamental equation that helps us understand the interaction between light and matter. It provides valuable insight into the optical properties of materials and plays a crucial role in the design of optical devices. Further research and advancement in the field continue to expand our understanding and application of the clausis-mossotti equation. Thank you.